Hi everybody, welcome to Vancouver Island, British Columbia, Canada. I'm not alone today. I'm with two geologists that most of you know from this channel, if I can find them. There they are. Jerome Lesemann, Gary Paull. This is a filming, scouting video for Brady Lawrence, and we're probably going to film a Nick on the Rocks episode here at this spot later in the summer of 2025. Thanks for joining us. Let's get started.
We're walking to this outcrop, but we're walking on the way there. We're walking on the Nanaimo Group sandstones and conglomerates. This is a mixture of, and it varies from place to place. Very coarse sandstone. It'll gradually transition to more conglomerate-like.
Okay.
And it's part of the lowermost unit of the Nanaimo Group, what's called the Comox Formation.
Okay.
Are these steeply dipping beds right here?
Right now, they're not super steeply dipping, but they're fractured quite strongly. So you end up with very blocky fracture patterns, but the bedding is essentially, you can see hints of the bedding through here. Here, this is primary.
Okay.
This, right, there's little bed forms, there's little ripples in places we can see. So it's shallowly
But
dipping
it's the
here.
fracture pattern.
The fracture pattern is what's creating the blockiness and the steepness of the faces.
So this Nanaimo sandstone will be part of this episode. If we want to do this episode here,
Yeah, I
there's
think you
two
would.
main rock units that we're featuring above and below this unconformity.
That's right. So we'll go this way.
This is quite striking, no pun intended. Like you're saying, this isn't bedding.
No, this is fractures.
Fractures.
This is fractures.
Why is it so fractured like? Why is it so organized fracture? This is so
Lots
unique.
lots of organized fractures. And remember that the Nanaimo Group is relatively young compared to what it sits on. So in the general stratigraphy of Vancouver Island for the rocks,
Yeah.
there's what most people think about as the Carmoutzen basalt, which is the main or the dominant unit on Vancouver Island, and it's part of the Rangelia. And then, but the Carmoutzen basalt is overlies a precursor set of rock units that we call the Sicker Group, and that's interpreted to be an arc, Devonian age. And then the Nanaimo Group comes on top of a portion of the Carmoutzen basalt surface, only on the what's preserved today on the east side of Vancouver Island. So most of this deformation obviously post-dates Nanaimo Group deposition and lithification, comes after.
Wow.
And is most likely associated with the Cowichan fold and thrust system, which is the Silesia crescent docking, the deformation of that happens as a result of that docking.
So yeah, I mean, we're excited about these cobbles, but I think maybe one thought is the Nanaimo's everywhere. We're here because of what's exposed below the Nanaimo.
Correct. Yeah, it's everywhere, but it's everywhere in a thin strip. Think of it that way. Aerially, it doesn't extend very far into Vancouver. There are patches that extend westward onto Vancouver Island, but it's mostly in the lowlands, what is today near sea level, and of course extends offshore into the Strait of Georgia today. But aerially, or geographically in its distribution, it's really almost a north-south strip of sediments. The bulk of them being between the Nanaimo and the Neuse Comox.
Yeah.
And then a little basin north of where we're going to be today, called the Suquash Basin, that's not as well studied, but probably correlative in many ways. So we're just starting to see some cobbles, and some places will become boulders in the sandstone. So we're just looking at, erosion has exposed underlying units of the sandstone. So there's a coarser unit beneath, and it's interbedded, because if you look at it here, you can see that, the rounded cobbles in the sandstone are here. So we're just, just because of wave action and erosion, we're exposing slightly older, lower, stratigraphically lower units, but they're just overlain by sandstone. And as we move that way, you'll see more and more of that. It'll just become increasingly bouldery and cobbly.
The cobbles look very diverse.
They are. Now the neat thing here when we come with students is that we're looking at this ancient deposit, but in many places that lower unit, that basal unit of the Nanaimo Group, is very much like the surface we're on today. It was a rocky beach, wave washed and wave battered, and you had rounded cobbles and sand and gravel basically on a coastal platform, which is exactly what we have today. So
Back to the future.
back to the future, exactly.
Okay, so you don't really like Nanaimo sandstone. Like if I'm trying to play with words with this episode, this is well, first of all, what numbers are we walking over? What
Age-wise?
range? Yeah.
Okay, we'll stick to the conventional numbers for now, and then we'll, there's a zircon story that of course throws some things topsy-turvy and all this aging.
Yeah.
But let's go with the typical numbers that people use, about 85 million, 87, 85,
Okay.
something like that.
Dinosaurs were around during this time.
Yes. So we're getting increasingly pebbly here.
My God, this isn't asphalt?
No, this is a pebbly conglomerate.
Holy shit.
And as you keep walking,
Ooh.
Are you kidding me?
yeah, lichen cover, but even fresher surfaces that way, we'll start seeing more.
So just to call it a sandstone is really not the way to go. There needs to be some way to describe that.
Yeah.
There's sexy goodies in this sedimentary package.
Yeah.
Cobbles all the way up to boulders, did you say? We're
Yeah.
going to see some.
Well, you were standing on
Whatever.
some of them. So when you look at the Nanaimo group stratigraphy, it's commonly just split into units that are dominantly sandstone rich, but that includes conglomerates in there,
Yeah.
gravels. In
Yeah.
some places, the gravels are prominent enough that they're marking the base of a particular unit. But there's sort of this split. There are mudstone rich units, and then there are coarser sandstone conglomerate units. That's sort of this very, very simplistic split between those units. And most stratigraphic columns of the Nanaimo group show you mudstone and coarser as a split. So this is sicker.
Oh.
Okay, we'll see it better over there, but this is essentially, so I've got 1 foot on the sicker, and I've got 1 foot on fragments of sicker incorporated into the sediment, the cobbles of the Nanaimo group.
So the reddish stuff right here.
Yes.
This is sicker and it's churty.
That kind of massive, very fine grain material, that's sicker, and then wherever you start seeing fragments that are often quite rounded, that's your Nanaimo group. And in places you see there's conglomerate in little crevices, because imagine that today you covered this beach in gravel, you'd have a very irregular distribution of gravel infilling little depressions and building up thicker in other places.
Oh, yeah, Gary's right
So this
there.
is-
Exactly,
this
that's
is
it,
the-
you're
Come
right
on,
at the
Gary.
unconformity.
So I got a 300 million year.
That's it. Your thumb
right
is
there.
300 million years, almost 250 younger than your index finger. Yeah.
Okay, so let's slow down here. So this I don't know if there's
More. Let's go over there and have that discussion over there, because
Okay.
you'll see it even better.
Even better.
Well, that's
Even
pretty
better
darn
than
good.
Okay.
I mean, that's dramatic.
Come on.
That's not.
Gary, I know you're just in Scotland and whatever. Like, this is nothing compared to what.
Oh.
Come on. This might be a World Heritage Site. Come on. Are you kidding?
So now you're on sicker. Just right.
God.
Yeah.
Nick, you're on a
Well,
chunk
it's
of the Nanaimo
totally-
group conglomerate, but we're on the actual bedrock of sicker.
So is he on a piece that dropped?
He's a-
That just dropped in.
He's
there,
just a
looks
frag.
like.
It's just a chunk. Yeah.
Yeah.
Just an old
Piece of
chunk
conglomerate.
coal. Okay, mind is racing now in a good way. Let's flesh out. So we have two. This episode is talking about two major stories on Vancouver Island near Nanaimo, British Columbia. And Jerome, freelance with the older stuff. You're calling it sicker.
Yeah.
How can we get the age range there? We're going back 450 million years ago.
Perhaps as much as that, but usually I think we'll put the upper limit at around 320.
320. Like, if we really just pick two numbers, what would you most
Let's go
comfortable?
300. Let's go 300.
300 for
We'll
this
make it
stuff,
simple.
and 85.
85 for Nanaimo.
Okay.
But of course, between the two, there's lots of time, and elsewhere on Vancouver Island, in that time interval, there's the entirety of the Carmoutzen volcanic package that is erupted to build the submarine plateau that then becomes Vancouver Island.
I don't think we talk about stuff that's not here. Like
That's it.
you know?
That's why this place is interesting, is because as much as there are lots of rocks, yeah, right there. As much as there's lots of rocks, there's arguably even more rocks missing here. And when I say, we have to think of missing a bit loosely. They might have been either completely eroded, they might have been fairly thin, but in terms of the time continuity of rocks that are present elsewhere, as we understand the stratigraphy, here there's a huge gap. A gap in time and gap in material.
But right over there's
Right over
the
there,
filling.
it's
That's the
exactly.
filling of the gap.
Okay, Gary,
Exactly. Absolutely.
which used to be here.
Maybe. Either was here, or some amount was here, maybe, or some was never here because for whatever reason, the way that the eruptions were happening, this wasn't fully covered or covered at all by volcanic rocks.
Okay, well, this
Who knows? It's
Who knows? But I think Gary's instinct is
It's over
like,
there. Why isn't
we
it here?
have
Yeah.
Huge German chocolate cake,
Yeah.
much older than ours in Washington.
Yes.
It seems pretty likely that
Some of it might have been
some
here.
of it was here.
Yeah.
But if I take this that we're on and we go underneath over there, it shows up underneath, essentially underneath there.
In places, yeah.
places.
We're going to run into more Nanaimo group, younger Nanaimo
Yeah.
group. But yeah, at some point you're going to step onto some basalt, which is the core of Vancouver Island.
Okay, we got an episode already. I mean, come on.
Oh.
This is way beyond.
All right, great. We're done here.
Right? Like so yeah, let's just keep talking about like we're going to get in tight here, I guess.
Wow.
Yeah.
We've got everything. We've got a backdrop. We've got Canada geese, which you must have planted here and just released. We didn't see that after you parked the truck, but you unchained them from the tree so that they would swim
Float
by right now.
They're on remote control. They're just floating by.
Oh, okay. Well, bring them back. Tide
get-
pools. I mean, Jesus.
Might get a sea lion in a minute. We'll see.
Okay.
I want a whale.
You want a whale, Gary?
Yeah.
Well, you'd be surprised. There's more than you think around. But
Okay.
yes, the Mona Lisa is this, right?
I got to get over there.
Yeah, I think over to the top there where Gary is the way to go.
Wow, and the Nanaimo is photogenic here. This is not a boring ass sandstone that we just looked at in Leavenworth. Nope, sorry.
Yeah. Sorry, Lebanon. Sorry, Aaron.
Right.
But there's our even better unconformity here.
Yeah.
So Nanaimo group, sicker, quite clearly, right? The contrast is so stark.
We're missing more than 200 million years of time. Put your finger on
Right here,
yes,
right that
there.
surface, right there.
That's an unconformity, a gap in the rock record representing missing time.
And it continues behind me. Here, I'll swing around. You can see it. Right through there, there's the base. Goes up a bit. Wherever the gravel starts is where we're back in the Nanaimo group rocks. Down here in this crevice, and keep going.
And
So anything like that. So the conglomerate's got nice rounded fragments in it. It also got some more angular ones. There's a big one here that's pretty angular. But that is a chunk inside the conglomerate, but it's a big one. I think it was, actually it is. So some pieces are really large and very angular, others are smaller and more rounded, because this was a beach environment. So it's so similar to today's beach environment. Imagine burying that hump in gravel and coming back 60 million years later and just seeing an outcrop of it. You'd have a mishmash of cobbles and sand and angular fragments infilling all those little crevices of the eroded bedrock surface. So the environment this is recording is very similar to the environment that we have today on the same beach. It was a beach back then too, probably.
So that chunk, that's a piece of sicker then.
That's a piece of
been
sicker.
ripped up.
Ripped up or fallen off a cliff, who knows, right? We don't really, we don't have the paleotopography.
And there was a piece right over there
Yeah.
of Nanaimo
Yeah.
that he was standing on that was ripped up and
ripped
sitting
up
on
and-
top.
Exactly, fallen off one of the outcrops.
So let's play with some ideas about what we would want to include in the words here.
Yeah.
So what are other choices for labeling this stuff down below? We're saying sicker, but
So what kind of rocks is it?
Or
Yeah.
any way to kind of label this 300 million year story?
Basement is a good way of thinking about it, because these are the oldest rocks of Vancouver Island, or nearly the oldest rocks of Vancouver Island.
Good enough for me.
But they're not the most abundant rocks of Vancouver Island, aerially.
Of course, it's the basement.
It's the well, the basement could be broad, and I mean it probably is, but in terms of where we see it, it's actually rare, because it's most other places it's buried by
Good.
kilometers of the basalt of Carmoutzen.
Good.
So it's accessible and visible in a few choice locations. Mount Sicker is the type locality south of here, Duncan. You have to go into the Cowichan Valley, and then you can access parts of Mount Sicker. Butto Lake, which is often grouped with Sicker, is north
back
on
in
the
there.
island. Same idea. You have to go inland of Vancouver Island, and then you start seeing outcrops of
And
it.
that lake's very bottom of the big pile of Carmoutzen.
Correct. Yeah, exactly.
Okay, so we're making this bedrock. What do we have here? Can you use your hammer? Is
I can use my
Is it
hammer.
fine-grained?
It's a difficult one to describe, partly because it's weathered here, it's fractured a lot, and it's also deformed originally in terms of its environment. As best we can tell, in places it's bedded, so it's got stratification. It's got some component that's sedimentary. Gary's got his hand on the
Yeah.
chunk where you can see the bedding pretty well.
Okay.
And so most of that bedding is fairly thin. It's very fine grained, so it's mudstones. They look a lot like graded beds of turbidites. Very fine grained deposits of turbidity currents. But what's notable about it is that it's extremely hard. It's really
tough
rich in
stuff.
silica, and it's got really this sort of cherty appearance. I'm not going to call it chert
Right.
exactly, but it's silicified, right? Lots and lots of silica that glue, at the very least, sort of binds it and cements it, but perhaps even more chert-like in appearance.
So
This
listen-
looks a little more churty here
Yes.
than it did like where we were picking up the
That's it.
other
So you can
pieces
walk
back
in different
here.
places and it'll look different.
More-
And in places it looks like it's all ripped up and deformed. Other places the bedding is more intact. So it's highly variable, which
But
makes it tricky to like,
it is.
pigeonhole into a category with a single name. But let's think of a
But we're trying with
Yeah.
with basement and with hard basement,
Yeah.
silicified basement, kind of fortified basement almost, and a rare chance to see the basement. You don't see it in the mainland. It's just here on the island.
Yeah. Well, I'm going to say yeah. I think so. I'm not
Okay.
sure on the
Right.
mainland, but I don't know. At least not around Vancouver. You don't see it.
So we can see the vertical nature of this outcrop is so illustrative with just this stuff's hard. So we've got these incredible kind of right angles essentially,
yeah.
and then it's so pleasing to then leave the 300 million year old stuff, go to the
85.
go to the 85, and
We call it 300, but it could be 280, 260, but it's
we're
in
going
that range.
300. I
Let's
like
go with
it.
3.
So let's do more with that. 300. This is the time of Pangea. So we're trying to talk about two stories, but I think it's definitely appropriate to throw in global geography here. That both of these units were not at this latitude and longitude.
Yeah.
We have to say that.
Yeah, absolutely. I think that's a fair. We can argue about how far they were, or
So that okay.
how much latitudinal difference there was, but I think it's totally fair to say they were not here when they formed.
That needs to be one of the biggest, maybe the biggest part of the episode, according to me. I'll be interested in what Gary has to say, but we're going to Vancouver Island,
Yeah.
but we're not really learning lessons about the history of Vancouver Island as far as a point on the map. We're going to
Yeah.
Vancouver Island now, but we're going to somewhere in the Pacific during the time of Pangea.
Yeah.
No idea if we're in the southern or northern hemisphere.
I mean, okay, so if we sort of roll back the events as we understand them, Carmoutzen basalt is hotspot related,
Which isn't here.
which is not here now. It's a large igneous province, so it's your submarine plateau, early phase of a hotspot kind of.
Oh.
The green chocolate cake, not your German brown chocolate cake, but ours is, our basalt's very green. It's been metamorphosed a bit and hydrothermally altered. So it looks more green, especially in weathered surfaces. So let's call it the green chocolate cake.
I'm going to interrupt you though, because if we make the case that Gary says, well, here's this thick pile of flood basalts that are 225,
Yeah.
and we're in the episode we're going to say the 225, at least a portion of it, we're here.
Yeah.
Then we can pin where we are
Yep.
because the flood basalts are tied to
to a hot spot.
Galapagos.
And
Some
yes.
researchers are saying that. So at least we don't know exactly 300 million years ago, but
we do know that, or at least it's proposed that the lowermost portion of the basalt
Yeah.
that overlies Sicker,
right.
the idea is that it erupts through this ancient arc. So Sicker is an arc system.
It's an
Arc
arc.
rocks,
It's a volcanic arc. Oh, Jesus.
Okay, so Sicker is a volcanic arc, and the peripheral areas around the arc. So we're not seeing necessarily the arc rocks here, but we might be seeing some of the sedimentary rocks related to the arc. Elsewhere, there's other outcrops of Sicker where the case for an arc has been made. But let's just go with the idea that it's an arc.
It's an arc.
And then there's eruption through that arc system by a hotspot that will then build up this submarine plateau that becomes the Carmoutzen basalt. And some people have argued that eruption is associated with the Galapagos hotspot. So we can say, if we go with that idea, I don't think everybody agrees on it, but let's just play it out just because.
Yes.
We could pinpoint, assuming that the hotspots don't really move much, the Galapagos hotspot, we know where it is. So that would place that arc and the eruption through that arc at that latitude.
That's precisely why we would talk about rocks that aren't here.
Right. But if you look at the Galapagos Islands today and the Galapagos hotspot, offshore of the north part of South America,
Right.
South America is nowhere near in the neighborhood when that's happening. It's some form of open ocean, because as you're saying, it's Pangea, right? Pangea is the time of Pangea. It overlaps with the time of Pangea, and Pangea is somewhere on the globe, but the hotspot could be all by itself in the middle of a plate.
This is so good.
South America
Is not South America
be-
yet, or
could be
near there.
further away.
Yeah, it could
to
be
the
further east.
East America.
and
Further
probably
east.
tilted.
Yeah, who knows, right?
Yeah.
Yeah.
Okay, just to finish this, because this is it, I think. This is the episode. Even we jump to the top and well, finally, we're so young, we have to be in North America. And you're like, oh, yeah.
Maybe.
Which part?
Which part of North America?
But we could say North America.
Yeah,
Could
yeah.
we say that?
North America, but
these
not at this
rocks-
latitude.
Not at this so 80. So now we're suddenly into Baja, BC.
That's it. This is back into Baja,
Although,
BC.
Jerome, you're saying that the lower part of Nanaimo, which
Yeah.
we're at,
Yes.
was maybe sediments coming from the west. Part
Yes, exactly.
Into the basin.
That's the thinking, is that the Comox Formation, which is the first unit over top the unconformity that marks the base of the Nanaimo group. So right there where
Right
your hand is on it, exactly. That's called the Comox Formation. And generally speaking, that unit and a few overlying units, still in what we call the lower Nanaimo group, are mostly westward derived, sediments are westward derived. So they're moving eastward, but they're coming from a proto-Vancouver Island Carmoutzen source.
And that whole thing at that time might have been still swinging in, or is it? It's already attached.
At 85, I think
It's
most
probably
people would
attached.
argue that it's part of that Baja BC block, however
Yeah.
big that is, and however far east it extends, but it's already attached in some form, right? Because most people associate the docking of insular terrain at about 100 million. So by the time we're doing the Nanaimo group basin filling, we've already attached, presumably. Right? But again, there's some wiggle room there,
Yeah.
I think. So I say westward derived sediments moving eastward into the basin, coming from Vancouver Island, or here, very clearly, very local source, right? Because
Yeah.
there's fragments of the Sicker
In
right
here.
here. And then there's some sandstones, there's a big class of sandstone in the conglomerate. So we've got a mixture of different. But yes, and as we move through the Nanaimo group stratigraphically into younger units, then there's a shift to an westward movement of sediment from an eastward source.
Which may mean possibly the whole chunk is sliding northward up along
The chunk is sliding northward, but what we're going to see in other places is that the basin changes. In some places, the basin subsides. So our sources of sediment, if you think of rivers eroding, providing sediment, those get submerged, and sometimes they reemerge. There's fluctuations in the basin, and you have to the east of here, you have the CPC or the plutons that are part of that block, and so they begin to supply sediment, including the option of having maybe sediments derived from Idaho batholith and all those ideas, right? Based on the zircon work and provenance and all those tricky questions.
So another way to pitch this is 300 million year old oceanic volcanic arc has to be equator or even further south, let's say.
Sure.
And then this is a river story. These rounded cobbles.
It's largely a river beach story. It's a river, and in some places like here probably it's a beach. It's a shoreline story. It could be a river. It could be a gravelly beach, as we have today, just in the Cretaceous.
But we're suddenly out of the South Pacific or equatorial Pacific.
Yeah.
And we are up here in North America somewhere we're
between,
out of the ocean. We're the river or a margin.
Well, the block is moving during Baja BC, right?
Yeah.
And so we're somewhere between, I don't know, Tijuana and the Columbia River.
I mean, I want these all to be cobbles from the interior of North America coming to the west coast of North America, getting put onto this thing as the mega whale goes north.
Not yet. These are coming from here, like very local, or from the west.
Or from the west. That's why Gary said that.
From Vancouver Island.
From Vancouver Island.
But we are on Vancouver, so it's from the west of here. But here, they're actually really locally derived.
Locally.
Right? Because they're made of fragments that look like Sicker.
Right, okay.
We're not seeing basalt clasts in here much, maybe a couple, but not tons.
Okay, well, Brady, this has to be an episode, and we're featuring this, and maybe Gary has a few thoughts right now about, is this just a stand-up like we were just doing, and Brady's like right here with the tripod, and this is our close-up stuff, and then what's he doing with the drone here? I guess we'll leave it up to him, but like, you
could fly this at low altitude, like you could fly around just to show the extent of the outcrop.
I think Brady's down here with the anemones in kind of the afternoon.
Okay.
Yeah, on a low tide day.
Looking back at this, and I think a flight around there, I mean, that's really cool. We got to get the tide low.
Yeah.
At the time
and the light
to film
right.
it.
If it's super bright, sometimes there's glare off the water. It's not great. But if it's low light, like late evening.
This is pretty damn good right now, too, I got to say.
Or like this.
Or flat lighting.
Right.
Yeah.
But this is a one of a kind. Like, he's not going to fly and see 7 more of this relationship.
No, this is where it's clearest.
Yeah.
I mean, we've walked all over this, basically, on the way over, here and there. We were seeing it. Gary had his finger on it, but this is the most obvious and easiest to frame.
And if we're lucky, we get, you said sea lions or seals?
Yeah, sea lions, seals, eagles. Depends on the day.
No
whales.
whale.
There's whales around here all the time. Orcas. Yeah.
Jesus. Okay. I mean, and one more thing, and I guess I'll keep filming, but I think we have what we need. How much, so we are talking about the Carmoutzen basalts.
Yeah.
How much of this scene is Carmoutzen?
At this, here, if you just look across without gaining too much elevation, not much.
Okay.
Because if the houses in the far distance, there's another point, that's Nanaimo group still.
Okay.
Okay, so we're building the Nanaimo group this way. We're starting, stratigraphically, it's building up this way into younger units.
Yeah.
So as we move in that direction, we're actually moving into younger units of the Nanaimo group.
Kind of as we approach the mountains.
Correct. And the Nanaimo
still
group
low.
exactly. You see there's a hill in the distance with a tower that's flashing.
The far
mid-ground, basically, right?
Oh,
so
mid.
that's
got it. Yeah.
in front of Mount Aerosmith.
Right.
Aerosmith, but above the tree line that we see. That hill, the name escapes me right now, but it's a conglomerate unit. So it's Nanaimo group still.
But Mount Aerosmith?
Mount Aerosmith is not. That is your Carmoutzen.
That's the Carmoutzen.
Yeah.
That's what Gary said. Okay.
Yeah.
So we can use, And the thickest, for the record, the Carmoutzen flood basalts at their thickest are how thick on this island?
8 or 11 kilometers or something in that range.
11 kilometers. How
So,
many miles
yeah.
is that?
Miles, 5 miles,
5 miles thick. Thicker
I
than the
think
Columbia basalt.
3 to
easily.
5 or a bit more than 5. Yeah. I'll double check it. It varies from place to place, but it's kilometers in thickness,
And we're
which
not-
is pretty common for a submarine plateau. So what we do know is that when you get to the upper portions of the Carmoutzen, it becomes emergent. Like it was not submarine anymore. So there are portions of the Carmoutzen that contain columns in the basalts.
This is an older Silesia.
Yeah.
Yeah, absolutely.
Submarine oceanic plateau
Same-
builds
same story.
big enough to get its neck up
And
above
submerged,
water.
it becomes emergent and then actually cools in contact with air and has columns and so forth. But early it's pillows. Like if I take you to a Carmoutzen outcrop around here, it's pillows all day long.
225.
Yeah,
But you get up to the very top up there, and
Yeah.
then you might find some columns.
exactly. Or further north in the island, there's a few spots where you're
Oh.
looking at some of the younger portions of the green chocolate cake of Carmoutzen. So yeah, it's a very similar story to Crescent Silesia.
And I just look over there and I see how much of this stuff eroded.
Yeah.
That's a
If
great
it was that
instinct.
thick, I mean, there's
Yeah.
there's big hollow areas up there,
Yeah.
and where'd all that stuff go?
Well, there's that
And-
pesky 2.8 millions of the Quaternary where you did a lot of work over that area, right?
Oh, you moved it south.
Or we moved it into the Strait of Georgia.
Yeah.
And south to Seattle.
Yeah.
It's in the Puget
in
Sound.
Olympia.
Yeah, Olympia, that's it.
It's a lot of dirt.
It is a lot of dirt. There's really good Sicker pieces there if you want to just have a look at it, just to see really what its appearance. Here it's quite weathered and it's got lichen all over it, but this is a little cleaner
it's
over there.
got spots there. You definitely see some of the bedding.
Yeah.
You got any good glacial striations over here?
A bit, yeah, in places you might, or some of them are, yeah. Wave washed or wave beaten surfaces get
Yeah.
very, very tricky. But here's a good, just a piece, but you see the change or the
Oh.
different sandstone conglomerate.
Well, that's solid gold. I mean, that's 35 minutes. Well, I'm not sure I'm going to edit the thing at all. Like that was everything that you'd want.
One take,
I mean,
no edits.
Seriously.
So we were just looking at a portion of the Sicker to try to just kind of understand what it is and what it's not. And it looks sedimentary, but it's also, you're standing on parts that are completely deformed, fractured. And when you start looking at what's behind you, you see hints of bedding, but you also see evidence that some of the bedding has been attenuated, kind of stretched and
Well, it just looks old.
yeah,
It looks 300 million years old.
old and beat up.
And so is most of the unconformity fairly flat where you find
No.
it?
It's-
Parts of it are...
It's here. I mean, we just walked over it again, right? There
Yeah.
are places where you have it here. This is arguably the unconformity. I mean, it is today,
Right, yeah.
that surface, but it's also, we're missing the Nanaimo group. Over there is sandstone from the Nanaimo group, and we don't see Sicker.
So it's just...
It's an irregular,
Yeah.
but I mean,
So it's channels.
it's channels, it's
Yeah.
irregular headlands. If we buried this, that's the way I always think it with my students, like bury this in 50 meters of gravel. You'd have high points, low points, thick packages, thin
Yeah.
packages, pinching this way, pitching that way, and filling crevices and gaps. And cut through it 50 million years from now, and you'd see pretty much the same configuration on this old shoreline. And we're just looking at this old shoreline. Yeah.
Final thoughts, Gary. Is this, what are we, where are we, by the way? What, is there Nanaimo?
This is called Cottam Point.
Cottam Point.
Cottam Point on the Nanoose Peninsula.
Nanoose Peninsula, which is connected to Vancouver Island.
Yeah, absolutely. Yeah.
Well-
Just offshore of Vancouver, the east coast of Vancouver Island, or it is the east coast of Vancouver Island, but just slightly offshore of the main. On the map, you can see we drove off the highway. We kind of go through a narrow area, and then the peninsula expands. So we're on that Nanoose Peninsula, but this is known as Cottam Point.
Is this the Strait of Georgia? Is this the Salish Sea? What's the difference?
It's the Salish Sea. Regionally, the big area of the Strait of Georgia and other places, what we now call the Salish Sea, that includes the Strait of Juan de Fuca and the Puget Sound and so forth, but people still use the term Strait of Georgia, and that's just off of where we were before. We were looking at it when we were looking at the Coast Mountains.
What's your preference for how we label this body of water?
I think it relates in part to what we're trying to describe, the region in question.
But what label should I use?
I think you're okay with Salish Sea,
Okay.
regionally, but I think Strait of Georgia is still an acceptable use of the term. But the Salish Sea recognizes the broader context of it, but also the indigenous component to
I see.
the region.
And does that basically extend up to right where you get to the narrow passages up here, like Johnstone
Strait. So when we go to Quadra Island,
Yeah.
we'll be very close to the entrance to Johnstone Strait. So I think that's where people kind of draw the boundary of
Yeah, that would make
But they will
sense.
include in that the fjords that go into the Coast Mountains, right? So some of the maps of the Salish Sea include, Night Inlet, Butte Inlet, all those big fjords that go eastward into the Coast Mountains, and the Strait of Juan de Fuca and Puget Sound. So you could think of Strait of Georgia as a subcomponent of the broader Salish Sea, and I think that's probably the right way
Okay,
to think of it.
here's another idea, mostly Gary. Like we could write this where we start with this, and this is the basement of Vancouver Island, a rare glimpse, 300 million years old, setting the tone, Pangea, and so on. And then we do one of the drones or whatever, we zoom over, we're like, uh-oh, we got something on
What
top.
happened here?
And then we get to the meat of the episode, which is the unconformity. Maybe that's because this is attractive.
Or you start with I can take you tomorrow. We can stop by in Nanaimo. There's some really good pillows of Carmoutzen and say, okay, most of Vancouver Island is this, except when you come here, there's something underneath that. So you could start with pillows, and then you say, okay, where's the pillows that we were seeing before? Because they should be here.
Or do we do that when we get over here and we have this missing 200 million years? It's missing here, but there it is over there.
Yeah.
And then it looks like these pillows. I mean, they were going back and forth between a couple places, which is
he's probably
gets
not
a
going to
little
want to do
trickier.
that, but maybe he would. Like,
It's just to get this idea that what's missing here, right? What's missing is what we typically associate with Vancouver Island. What makes up the most aerially and in terms of thickness are the pillows and the basalt of Carmoutzen.
or we do Carmoutzen almost as something on
I
its
was
own.
just about to say.
Because
do
we
that.
got the large igneous, very large
Igneous province part of it.
very large igneous province. So that's
And there's some
like
really
a lip.
easy access outcrops with beautiful pillows in Nanaimo, again on the shoreline. Easy to find, easy to access, easy to film.
Jeez.
We can stop in tomorrow.
Yeah.
On the way back, I'll just show it
Yeah.
to you. It's a 10-minute walk. It's easy peasy.
Okay.
Yeah.
Okay. Okay, you're 1 for 1, officially, okay? You're 1 for 1. I'm keeping score.
Oh, we're going to quit where we're headed. We're going home now.
Wow. Thank you.